And hello again, this is the second part of the multi-series, which would be the solution for the chapter 5 worksheet. I think we're going to do the other questions. The other questions are for mass spectrometry. And I just decided to start the slideshow for some reason, so let's try to find that question. Hopefully by the time you're watching this, we have covered all of this exciting content, that is the mass spectrometer. And we're going to move on to question 5. I hope you didn't hear my cousin in the background just then. So you need to calculate the relative atomic mass based on this mass spectrum. Now this is just a different way of representing the information, obviously. Instead of giving you the actual abundances and the mass of the isotopes, you need to read it off the mass spectrum, which is this graph right here. It's very, very straightforward. The number of signals, or the number of peaks, indicate the number of different isotopes. So I have two different peaks. That means two different isotopes. And the actual scale, I mean, it's really clearly labeled, so there shouldn't be any problem here. This is going to be the first isotopic mass of 35. And even the percentage abundance is very easy to see. You obviously can see that it is 75% abundance, or I'm just going to convert it to 0.75. It's easier to do the calculation later. And for the second one, the isotopic mass is 37, and obviously the abundance will be 25% or 0.25. So the only difference between this type of question and the one that we did earlier is that this one you had to extract the information from the graph. Now this particular question is a very easy example of how the graph can be represented, but I think later on we may see a few other, or at least one more time, when you do need to calculate the percentage abundance based on the height of the peaks. But this one's very clearly labeled for you. So, okay, and I'm just doing the calculation here, and you should get the atomic mass to be 35.5 known units.